In this video, we're going to wrap up our Eigrp IPv4 section with some of the miscellaneous topics when it comes to Eigrp. Now, some of the stuff that I'm doing in between the videos, so the way, if you've been following, I just finished up the filtering section, and then now I'm going to do the miscellaneous features for Eigrp. What I'm doing in between these is there's obviously a few topics here and there, a few items under each category that I've touched on previously. It could have been a year and a half ago, it could have been 3 days ago. So there's some topics that I'm not as familiar with, so I have to do a little bit of digging to figure out, okay, what do we got to do to get it working? So, for instance, Eigrp route tag enhancements, we're not going to look at that in this video. The reason why is because this is normally used for redistribution, because then you can tag a route and have it use it to be redistributed into another protocol. The cool thing about route tags, if you decide to go out there and Google Eigrp route tag enhancements, there's actually a lot of really cool things you can do with it. Instead of underneath the route map, instead of stating that you're going to set tag 10 and you have to remember what that tag is, you can actually set the tag to the actual route that you're advertising or you're trying to match on instead of like a prefix list, and then you can match on that tag later on. So it's going to make it that much easier to identify, and then you can get real granular with your matching. You can match based on the binary match. So if you're familiar with binary ANDing and logic, you can go in there and say, for instance, you want to in the third octet you want to deny all odd routes. So for instance, you could specify your subnet or your network statement, and then your wildcard. In the third octet you could type in, it would be 0.0.1.0, and that would block anything that's odd in the third octet. You can do the same thing in route tags and give it the same kind of feature. Now we'll talk about this more when we get into redistribution, because it's going to be more applicable there. However, you can go in there and you can do a route map, and you can like redistribute something or do some other interesting deployments, and you can set a route tag and things like that. The main point of that, we don't really want to mess with route tags unless we have to. Like I said, they're a redistribution enhancement, so it makes it easier when you're going through your tagging and things like that. What we'll cover is going to be all of this stuff right here. That's what we're going to be covering in this video. So we'll start off with the Eigrp default network. Now all the Eigrp default network it basically does is it's going to take a classful route. So classful based on the subnet, the IP address you choose, whether it's an A, B, or C classed range. And then what it's going to do is it's going to actually, in newer iOS code, it's actually going to advertise a static route to wherever it is you're learning the route from. So for instance, if we're learning the route from 10.1.120.11, so we're matching this route right here, and we do a default route, or if we do a default network, it's going to make this the gateway of last resort. So you need to be careful where you're learning your routes from. So same thing with this guy. So we're going to see if 18 is where we want to go, we would have to plug this in, and as long as there is a route in the routing table, we can use that route as an IP default network. Now, typically speaking, you're going to want to do this upstream of where you're going to be pointing routes towards, because you're not going to want to route traffic this way. You're going to want to route traffic this direction. So it's going to be much more efficient to route it that direction. So what we're going to do is we're going to take this 10.100.18, and I'll show you why you need to have it set up a certain way. So we're going to type in IP default network, and we're going to type in just this .0. So IP default network, and we're going to type in that .0. But let me preface this with, we don't actually have a 10.100.18.0 route in the routing table, and you'll see what happens. Okay, so we're going to type in do show IP route, and if you notice, nothing actually gets advertised. The reason for that is because we're matching on just this section of the route. It's a /32 that we're receiving in from router 18. So we're going to type in, we're going to hit the up arrow a couple times, type in no, and then we're going to hit the up arrow again, go back to this, and we're going to type in .18 and hit enter. So that should advertise the default network in for us. If we do show IP route. Let's see here. Well, it's not doing it now. Let's see here. Or is it? I don't see a static route either. Okay, let's pull it out real quick and see if that makes any difference. Yeah, actually it did. Before we had a static. So if we look right here, we had a static route right here. So if we go back and we do the IP default network, and we do a do show IP route, pipe include S, we have a static route. Now if we take that out and do this, we don't have a static route. So it actually adds in a static route for us right here. Now that's pointing us up towards R18. So what if we did it? Can we do it to more than one subnet? Let's try. So I'll plug that in, do a show IP route. Okay, there it goes. Now what we're going to do is we're going to whack that, and we're going to take a look at the entire routing table. So we have that static route in here. What we're going to do now is we're going to say going up towards 18. Do I have anything else going to 18? I have the 8 network, but I don't want to point to that. Let's just say, for instance, this route right here. So we're going to copy this route right here, type in IP default network, and we're going to type that in, and we're going to hit enter, and do show IP route. You notice how we got 2 in there now? We have a static route pointing to here, so if we do this, let's do a show IP route, pipe include S, and we're going to do, I think it's whack that. So what we get in here now is we have technically 3 different ways of moving through our network. We can go for the 10.8 network, 10/8 network, we can go towards anything 10, we can go towards router 18 for. Okay. Now we have a default route, a straight up default route, going from via router 11. So that would be our route, a static route pointing up that direction. Then we also have this 192.168 network in here, and we're pointing towards router 11 as well. Now I wonder if I take this out just to the star. Yeah, see, it doesn't know how to match it. So I need a regex to grab that. So that shows that we've got that extra route in there. Now if I was to do this and take all this out and do a show IP route, and then I have this 172 pointing out here, if I was to take this route and do it on any other router, if we go to router 11 and we do a show IP route, notice how we're not getting anything. There's no star in here. You gotta be careful with this command because it doesn't actually do it on a per hop basis. Or I'm sorry, it doesn't propagate the information. You have to do it on a per hop basis. So if I wanted to set up a default network, I would actually have to go in here and say we're gonna go. We don't actually have a default route right now. So if I was to type in IP default network, I'd have to type in 18, and I'd have to type in 19 or 19 and 20, which would be the logical choices. I would have to, let's do this. Let's do this guy, and then we're going to go config T, IP default network, right click and paste that, and then we're going to do a do show IP route, pipe include static. So now we have a static route in there. We're also going to do the up arrow. We're going to take the 20, put 20 in there, and then do a static. Now it takes the 20 because they're the same match. So if we're matching the same classical range, so if we're in this part right here, if we're matching the same classical range, we're only going to install one. But if we're classifying multiple ranges, we can install more than one static route, which is the case with router 20. So that's why it's important to understand how this stuff really works. So it's one of those things where I'm like, well, what happens if we do this? Now, sometimes you might not think to try that. So this is why I'm like, okay, well, let's give it a shot. You know, it couldn't hurt anything, right? It's a lab environment. That's why we're labbing. So that's the default network. Now, if I was to go to 18 and do this the same thing, if I was to type in router Eigrp1, no 3, and type in address family IPv4 address family autonomous system 1, and then I was to try to do the same thing here, or I'm sorry, what am I doing? IP or do show IP route. We're going to have all these routes in here, right? And we have a default route right here. Or no, we don't have a default route. We should have a default route. We were going to have the 101. This guy. We're going to have, this is our 101 network. 101.8. We're going to have, this is our default network. This is going to be our default network right here. Now we're going to copy this, well actually just this. We don't actually do this. We're going to go to global config, or type in IP default network is going to be this, and hit enter. Now we type in do show IP route, pipe include S. Now we have a static route towards that. Now what's going to end up happening is we go to 20, doesn't add it. Notice how nothing changes. Well, technically speaking, we do actually have one. So if we were to go to router 18 and do this and type in no, and then we were to go to 11 and do a 11, not 20, 11, and type in a, we're going to say do trace to 4.2.2.2, we're not going to be able to go anywhere because it doesn't propagate the information. So what we'd have to do is we'd have to go on a per hop basis and advertise that. So we'd have to say, if we're going to be doing that, we're going to do the up arrow, and we're going to say to 19, and we're going to do a trace, and then, because it doesn't match though, but it should, because it's a 10 network, so it should match anything 10, but it doesn't. So we're going to do this. It should match that and go send it up there, but then again, we don't have a default route. So how would we accomplish that? We'd have to go to router 20 on the interface pointing to this way and advertise a summary route of all zeros and make it a default route. Because in named mode you can't do a default route. There's no default information originate. You can do a default network. Now you can also do a default gateway, but the default gateway is designed for the router being turned into a with IP routing turned off to where it's just an end host. So the capability is there, but normally it's not used. So at the end of the day, what you need to do is on R11, or I'm sorry, R18, you need to go to config T. Actually, let's do this. Let's type in that. We're going to go to so I type in do show run pipe include static, or IP route I should say. What's going to end up happening is there's not going to be a IP route command. I never issued that command. But if I type in do show run, do show IP route include static, there is a static route in there. I didn't configure it with the IP route command, but this injects the static route into the routing table. Now what I can do is I can go into router Eigrp 3, and I can type in address family IPv4 autonomous system 1 AF interface, or sorry, AF interface fast2/1. And I can type in the IP or the summary address is going to be I can type in 0.0.0.0, and I can /0 and hit enter. Now it's going to cause a reconvergence, which is fine. And then when I'm going to go to 20, I'm going to do a do show IP route, but I'm going to take all this out. Now I have a default route, but it's still pointing to router 11. So now we got a problem. But I also have another default route pointing here. So then it becomes a matter of, okay, which direction do you go and how do you solve this? Well, we already know one way to solve this problem. And actually it took the route out because we're no longer advertising the route to router 18. So that loopback setup that we have wouldn't work. So we'd actually have to go in there and take that static route we had to take all that static routing out, and then we'd have to go in and redistribute static, or redistribute our default route is pointing to that. So we'd actually have to do summary address as well. But the idea is to take all this extra stuff out. So we're going to do, I should be able to take this command out. I should be able to type in no to that, and then no to this guy. Do show run pipe include IP route. I didn't type any. I didn't put a static route in. That's got to be coming from. Okay. So the nice thing is you can type in default dash network, and it'll tell you what else you got running. So no, and then you can take this guy out. So we have that taken out, and then we're going to do show run IP, do show IP route. So now we're getting the route from router 18. So now we have a default route advertised in, and then we have we'll go to router 11, and then router 11 should be getting to router 18. So that's how we would get our route out to that direction. So as long as you have a route out to the neighborhood, you should be good to go. So at least that gets us where we need to be. So, but that's the default default network. The default metric command is actually pretty easy. If we were to go to router Eigrp 3 and type in address family IPv4 autonomous system 1. Oh, router, forgot about that, Eigrp1, and we're type in default metric, which is right there, default dash metric, question mark, and then whatever we wanted the metric to be. Now this is going to be the default metric for any default routes. So if you have a default route that comes in, or if you want to redistribute anything in, this is the value, the metrics that it's going to inherit when it does redistribute. Or you can do redistribute Ospf 1, and then you can specify the metrics there. Or you can go to the route map and type in redistribute, and then you can specify set the metric, and set the metric in the route map. So either way works. There's 3 different ways to skin a cat. So you can go in there and set the metric in the route map, set the metric in when you're doing the actual redistribute statement, or you can do a default metric, and every route is going to be every protocol that's ever redistributed into Eigrp is going to catch this default metric. So we'll say, whatever. We'll say we can get away with saying one. We can get away with saying that here, and then we can take and redistribute a route in. And so, for instance, we'll say we'll actually create another loopback interface. Let's type in interface loopback to, we'll say 1000. Type in IP address is going to be 10.100. Or you can't do that. I'll do 192.168.255.11. And it'll make it a 32-bit route. We'll type this, and we'll go in router Eigrp1. We'll type in redistribute. We gotta actually create a route map though. Sorry. Route map. We'll say Eigrp. We'll say match loopback, match interface loopback 1000. And then we'll go to router Eigrp1, type in redistribute connected, and then we'll say route map Eigrp, and then what it's actually going to do is we can specify the metric, but we've already done that. So we're going to go to router 20, and we'll go to the upper do show IP route. We should get a route update in here. We are. And we're getting the route in. There's no doubt about that. We got the route in here. But I was expecting to see with the external. Why is it not showing up as... That should be a really, really bad metric. So let's do a do show IP route. Shows up as a connected route. What about 18? What does 18 see it as? '18 sees it as a connected interface with the same metric. See, my intention with that was just to see a really, really bad route advertised, because all ones in normal Eigrp, it should be like a 2 point something billion metric, which right here we're 2.7 million, which is way better than 2 billion. So it's advertising, no big deal, but that wasn't my intention. The default metric, when you redistribute something in, we'll take a look at this when we get into redistribution, but that's going to be one of those things where you have to understand what it is that's happening with the default metric. Now, the neighbor logging is actually really easy to do too. So you can actually exit out of here. You can type in Eigrp from main mode, where before you dive into, this is what I'll call the main mode right here. And the reason I call it that is because you haven't gone into the interface, you haven't gone into the topology, and you're here the ability to advertise networks and neighbors and timers and things like that. So this will be the main mode. So we have Eigrp, and you can set up a default route tag, which goes into conjunction with the route tag enhancements. So you can type a default route tag, and you can set up whatever you want. You can set it in plain format. I prefer dotted decimal because then it makes it more intuitive. So you could say, literally, you could just type in 0.0.0.0, and that could be your tag. Now, I wouldn't recommend doing that. I would actually recommend doing all 255s. The reason for that is because typically when you're going to be specifying that your all 255s is going to be a wildcard to say just those bits. So that's typically how I would refer to it. But the main focus of this one was neighbor logging. Now, if you want to do neighbor logging, you can totally do that. The way you would do this is log neighbor changes. You can turn this on or off with the no command, or the Eigrp log neighbor changes. By default, both of them are on. So actually, this one is on, this one is off. So we type in log neighbor warnings, and then you can specify the warning interval in seconds of how often it's supposed to be warning you the changes are happening. So I don't prefer to use this. It's actually easier to use. My personal preference to notify logging warnings and stuff like that is actually to use the debug IP routing, because then you can actually see neighbor adjacencies flapping, and when they go down you'll see it, when they come up you'll see it, and also IP route profiles, because then it's going to log the changes over a period of time and show you how often they're flapping. And it doesn't. This one's specific to Eigrp, obviously, and this one will tell you, hey, Eigrp is flapping. This is what's up. Where debug IP routing is going to tell you what protocol bounced and what subnet and where the neighbor is, and then when it did it. This one here, it does the same thing, but the thing is, if you're not logging correctly, so you got no logging is turned off, or you don't have a buffer, it's technically speaking all three of the above. So the IP route profile, the debug IP routing, and this one would be kind of pointless. They wouldn't be saved. But so that's how you would do that, and then it kind of follows suit in this same area with the router ID. So router ID, and then you specify whatever that is. So in this case, it's going to be 10.100.18.18, and then you'd be able to go in there and so 10.100.18.18, and then question mark, and that's all there is to it. I mean, it's very, very straightforward. The stub command, we've covered that already. The stub, and then you have your options of, by default, it's connected in summary, and if you wanted to advertise receive only or redistributed or any of these additional commands, you'd have to add that on top of connected in summary, or if you don't, they'll go in here and they'll override it. So if you type in Eigrp stub receive only, then connected in summary will be disabled and go on from there. So that's that. Now, no next hop self, no ECMP mode. This is typically used in regards with DMVPN. So basically, what's going to end up happening with no next hop self, if we were to go under the AF interface, so AF interface fast2/1, and type in no next hop self, and then no ECMP mode. Basically, what this does is, normally what's happening with next hop self, by default, Eigrp by default sets the next hop value to the local outbound interface address for routes that it's advertising, even when advertising those routes back out the same interface they were received in on. If you change this, you can use no next hop self to tell Eigrp to use the received next hop value when advertising these routes. So if R20 advertised it to 18, and then was supposed to, and 18 received it and advertised it to 19, 18 is going to advertise it to 19 as if it came from 20. No ECMP mode is an enhancement to that. When it's used, all paths to a network in the Eigrp table are evaluated to check whether routes advertised from an interface were learned on the same interface. If the route advertised by an interface was learned on the same interface, the no next hop self configuration is honored, and the received next hop is used to advertise the route. So it gives you a lot of flexibility, and it's typically used in dynamic spoke-to-spoke tunnels inside of dynamic multi-point VPN, or DMVPN as for short. So gives you some flexibility here. Now, if you're going to use no next hop self, you must also disable split horizon, which will be done at the same interface. So you'll be able to go whack, and type in no split horizon, and then hit enter, and that would take care of that problem as well. So the cool thing about it is it gives you a lot of flexibility. So as you can tell, there's quite a few options that are available to Eigrp, and like I said, we'll take a look at route tag enhancements. But to give you guys just a quick check on how that would work, if you were to type in route-tag, and then you were to type in notation is going to be dotted decimal, and then you would hit enter, and then type in route-tag, route-tag, and list. And you could create a list, we'll say Eigrp, question mark, and then we're going to permit, and then you could specify the range you want to permit. So for instance, we'll say 10.100.18.18, and then we're going to specify a wildcard of 0.0.0.0, which means exactly this route, question mark, and an enter. That means that this is going to be a list you're going to be able to call. So now I can go to a route map, route-map, and type route-map and say Eigrp as well, and type in match, and it says route or match tag right there, question mark, and then the list, and then the name of the list is going to be Eigrp, and then the tag list name, and then you can go. Oh, you can specify more than one. That's what that means. That's what this means. Because I was like, wait a minute, list. Tag list, and then there's a name, and you can go and do it again. So you have to list at least one, so Eigrp, and then you can list another one if you wanted to. So you can list multiple ones if you'd like, and then go from here. So you could actually go in and say you could specify this guy to be, R18 loopback, and then whatever else you want to do, or R18 192.168 3.2 route. You can get, like I said, you can get very specific with your matches, and then from here you can match tag, and then if it matches, you can deny it on the set to, what have you, and stuff like that. So it gives you a lot of flexibility in that regard. But that's just a general overview. We'll take a look at this in much more detail once we get into redistribution, because we'll be going back and forth between a couple of routes. So the idea behind this is when we're going through. Now, which most people, if you're at this video right now and you're listening to this video at this certain point in time, right now I've actually got Ospf running up here and over here, and BGP running completely through this entire network, and most of MPLS configured. So it's going to be the BGP peering here and allowing the traffic to go back and forth and stuff like that. Let me flip over to the pencil so I can see where I'm waving my pen here. So the idea then would be to go make sure you understand where you're going with this stuff. So what I would actually recommend doing is if you're following along and if you've got this topology spun up, or you're doing a section of routers at one time, go in and practice your redistribution. Go in there and start getting redistribution routes and type in, default route here or default route there and stuff like that, or do some sort of rip routing between that and stuff like that. Play with it. Get familiar with the technologies. That's what I'm doing right here. If I'm not sure on how something works, I am always going to pause the video and I'm going to go Google it. Because I'm not going to give you guys bad information. Because the minute I start giving you bad information, and because let's say for instance, you can't afford to go out and spend money on like some sort of vendor's training. So you're coming here for these videos. Great. Happy for you. Thanks for watching. If I give you bad information and you go to an exam and then you answer a question based on information I gave you and you fail, then you're going to hold me accountable because I gave you bad info. So I don't ever want that to be the problem. So that's why I do my best to give you guys good information. So it also helps me because if I can't pass now granted we're all studying for I'm studying for my CCIE. You guys are not, or you may be, but that ultimately falls on my lap. So I have to prepare myself for the lab. You don't prepare me for that. So, but anyway, that's my take on the situation. So that's it for Eigrp with IPv4. I wanted to run through some commands and just show you guys how that would work and get some breakdowns going. So we're going to get into Ospf in the next section, and there's a lot for Ospf. I don't know if you guys are paying attention or if you guys saw this or not, but there's a lot for Ospf. Matter of fact, if we were to come down here, just alone, when it comes to network types, we have a lot of details to go over. So we're going to cover all the network types and virtual links and stuff like that, and cover exactly how that's all supposed to work, and auto cost, and modifying the bandwidth, and per neighbor cost, and dealing with all the authentication that goes along with it. And then the main thing we're going to spend a lot of time is going to be on sub areas and translators and stuff like that. We're going to spend a lot of time on that. And because the reason why we're going to spend so much time on it is because I feel like it's the between the filtering and the stub areas and understanding the database, I have a feeling that Ospf is going to be a very large portion of the exam. So if we go through, we start labbing this stuff up and really dig into the context of it. So if I feel like I did a really good job going through the technology videos themselves. What this section is doing is allowing us to kind of deep dive and say, okay, well, we're not limited to that topology right now. We've got a lot of room to grow and a lot of things to play with. So now we can go in here and play with different options and get in there and actually go with stuff. Now, if you don't know what a NSSA Type 7 to Type 5 translator election is, if you don't know what that is, or you don't understand the process of the p-bit, which is actually going to allow you to translate and propagate a Type 5 external LSA out of a not-so-stubby area into other areas of Ospf, if you don't know that, then you need to go back to the technology videos and go look up the NSSA videos I did, because that's going to be a major factor when it comes into this, because you can actually, if this right here is broke, if this is not allowed, then you won't allow Type 5 LSAs outside of into your Ospf domain. Because the whole purpose of a not-so-stubby area is to be a stub area, so to slim down the routing table, but also allow external routes into the table. So they're actually brought in as Type 7. So that's why they're allowed in the area. So if you redistribute a Type 5, that's going to get flipped over, and then there's going to be a forwarding address, and it gets more complicated. So we'll take a look at that in a lot of, like I said, we're going to take a lot of detail, take a real deep dive look at this and see exactly what it is, run through the commands, make sure we know what's going on, and I think that'll be a good benefit for everybody to take a look at in detail, because that gives you a real deep understanding of what's going on. So knowing how that works is definitely going to be a key factor, and I have a feeling that some of these other features down here, we've covered most of them. With we haven't covered single hop LFA. Actually, what I have to do is I have to actually go back in and do a what do you call it? I have to do a. I'm catching a blank moment at the brain fart. I actually had to do a video for both Ospf LFA and Eigrp IPFRR because of the fact that I did not do those yet. So I had to do those as well. And then we have some other things and stuff like that to cover. So, like Ospf v3, we're going to be we'll take a look at Ospf v3 and see exactly what that is. A lot of the commands for Ospf v3 are directly mapped to IPv6 Ospf. So we'll take a look at that in detail as well, because it's important to make sure that we understand all the multiple factors and how things go into play. And we'll be looking at encryption and going into detail on that. So, actually, a friend of mine that's following me along with this section, he basically was like, well, you got your technology videos and you have your lab videos. Basically, all you're doing is you're cutting out the whiteboard. I go, pretty much. For the most part. I mean, there's going to be other things that are going to be brought into play that are going to be necessary evils, but this is going to be a big portion of the exam, is going to knowing the IGPs as well as we're supposed to. Now, at the same point in time, I'm also taking the time to go through these labs, knowing this stuff down to this is a per feature, is what I'll consider all these. These are a per feature, or individual items of a category. So going through every item in every category and making sure you know how to configure it, how to verify it, how to troubleshoot it. Because come lab time, you're not going to think about it. You're going to be like, okay, I'm familiar with that. I can look at that. So, like I said, there's not a whole lot here that I don't know. So I'm actually using this as my, okay, do I really understand this? Okay, I have to go back and I have to take a look at database filtering, because I'm not exactly sure what they mean by database filtering. And this is actually a good place for all of you to check out too, because if you don't know what database filtering is, that's something you got to go Google and say, okay, what is Ospf database filtering? And then look up some white papers on it, read some documentation, okay, and get familiar with it. So that when you get in the lab and they're telling you to do a filter based off the database, or filter out this type of LSA, well, an LSA is going to be in the database, not in the routing table. And you might be thinking, well, what's the difference? Well, if the best routes in the database get installed in the routing table. Well, if you want to prevent something from getting implemented in the routing table, you can filter in the database. So I understand what database filtering is. How to actually do it, I don't know. And you'll find that I'm rather a friend of mine calls, what does he refer to me as? I am brutally honest. I'll tell you straight up whether I know something or not. If you were to read my resume, it's like I'm an open book. If it's on my resume, I know how to do it. If it's not on my resume, I don't know how to do it. So I'm kind of the same way here. So, but anyway, hopefully you guys are enjoying the videos thus far. Actually, even though at this point in time I have not uploaded anything, so when you guys start watching these videos, obviously they'll be uploaded by that time. So, but anyway, I hope this has been informative for you, and I'd like to thank you for viewing.